Okay, welcome to the 14th class of Computer Architecture and Organization. So, in this class, we are going to discuss about what is mean by operational code in detail, and what is mean by addressing, and what is mean by memory locations. All these things we are going to discuss in this class. Okay. So, first of all, what is mean by opcode? I think we have already discussed about opcode and operands in our previous classes, isn't it or not? An instruction consists of two parts. One is called as operational code, which is simply called as opcode, and the second one is operand. Okay, that we have discussed already in the previous class. But now it was given as a separate concept, so we need to discuss about it to some more extent. Okay, in depth we are going to discuss about this operational code. So what is the thing, or what is the idea that the writer is going to give to us is what he wants to say is uh, we are till now we have discussed about different types of instructions, is it or not? So different types of instructions are used to perform different types of tasks. That means in order to perform addition operation, subtraction operation, we are having different types of instructions. For performing shift operation, we are having different instructions. Similarly, for transferring the data from one place to another place, we are having different types of operations, isn't it or not? So here also till now we have discussed about different types of instructions which are used to perform different types of tasks like addition, subtraction, data transfer, etc. For different types of operation, we are using different types of instructions. Okay, every instruction consists of two parts. One is called as operational code, and the other one is called operand, that we have discussed in the previous class in depth, isn't it or not? So what is the operation we are going to perform will be specified by the given opcode. That means if you want to perform some addition, then we will write the instruction called add. If you want to perform any subtraction operation, then we will write the instruction called sub. If you want to perform any multiplication, then we will write a name as instruction as mul. Here the add, sub, mul. If you want to transfer the data from one place to another place, we will use mov. These all are called as operational codes, or simply called as operands. Why these are called operational codes means, for performing addition operation, we are writing a code language which can be understandable by that particular processor or controller. Okay, for transferring for subtraction operation, we are writing an instruction called sub, which will be understandable by that particular processor or controller. So we are writing a code language in order to perform the desired operation. That means whatever the operation we want to do, or we want to make the processor to do, we are making the processor to do that particular operation by writing or by giving an instruction that is understandable to that particular processor. It is called as operational code. Okay, on whom we are performing this operation. That means if I want to perform some addition, I need two numbers now. So those two values, I need two values. Those two values may come from two different registers, or one from the register and the other one from the memory location, like that, isn't it or not? Or one is from register and the other one is immediate value, or one is from memory location and the other one is immediate value, like that. There are different ways from where we are going to get the value. Okay, so those will be called as operands, and the operation what we are going to perform is called opcode. Okay, here what is the thing he is specifying means, the operation, the instructions may use operands of different sizes. That means some operands may be of only 8-bit, some operands may be of 16-bit, some operands may be of 32-bit. How can we determine means, based on the operation what we are performing, or from where we are going to get the data. That means if there are any instructions like INC, increment operation, decrement operation, they may be of only 8-bit. If you need to perform any addition or subtraction, they will be of 16-bit. If you want to perform any multiplication, they may be of 32-bit. Okay, like that, we are having different types of operands like 8-bit, 16-bit, 32-bit, etc. Okay, so that's again the last this paragraph gives the information what I have told you previously. The type of operation to be performed and the type of, this is not TU, it is type of operand to be used are specified using an encoded binary pattern called as opcode. Okay, so what does the opcode specifies means the type of operation to be performed and the type of operands to be used. That means the type of operands means if I want to perform addition, okay, then I used an instruction called ADD. So if I want to perform addition, I need two values. Okay, from where those two values may come? They may come both from the registers. That means here the type of operands are registers. Okay, or one value from register and the other one may be from memory location. Here the type of operands are register and memory location. Okay, or one is immediate value and the other one is from what you call register. So here the operands are immediate value and the register. So though the operation is same, but the operands may come from different places. Okay, opcode will deal with both the things. That means the opcode will deal with the operation what we are performing and the type of operands we used and the type of operands we are used. Okay, so all together, see, that's what they have mentioned here, the type of operation to be performed and the type, this is not TU, type of operand to be, it is one B only, B to be used are specified using an encoded binary pattern. This is called opcode. So the opcode will be generally in a binary form. That's what they are going to discuss about this operational code or opcode. Clear? Next. So here they have given some example. See, here there is an example called add R1 comma R2. Okay, here what is the operational code? ADD. That means here we are going to perform addition operation. So if you want to perform any addition operation, we need at least two values. Okay, here the two values are coming from two registers named R1 comma R2. The two values are coming from the two registers called R1 comma R2. Okay, na? That means along with the operation what we are going to perform, opcode should include the type of operands that are present. That means the opcode will give the information of the type of operands also. That means whether both are registers or, for example, I can write something like this, na? ADD add space R1 comma 55H. Okay, here one operand is register and another one is immediate value, and I can also specify some example like ADD add space R1 comma content of 5000H. So whenever you see this content means what does it indicates? Content indicates the memory location. So here one operand is register and the other operand is a memory location. So that means the opcode will not only give the information about the type of operation we are performing, but also the type of data operands we have used. Okay, so that information also is stored in the opcode. Here if you observe, here the two operands are registers, but here one operand is register and the other one is an immediate value. Whereas if you observe this third example, one operand is a register and the other one is from the memory location. Okay, next, what he is trying to say is this is the concept that will come in your STLD also. For example, if I have 3 bits A, B, C, how many different combinations I can get in your STLD? I have 3 bits A, B, C. How many different combinations I can get? I can get 8 different combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0. I think you all are familiar now, isn't it or not? Or I have to specify? See, I have A space B space C, 3 variables. How many different combinations I can get? I can get 8 different combinations. What are they? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, triple one. Okay, isn't it or not? So if I have three variables, I can get 2 power 3, 2 power 3. That means 8 combinations. Similarly, if 8 bits are allocated for instruction encoding, that means if the opcode is of 8 bit, if the opcode is of 8 bit, then how many different instructions are possible for that opcode means 2 power 8. Just like this example, if I have three different bits called ABC, then I have 8 possible what you call 8 possible notations. Similarly, if I have 8 bits, if 3 bits means I got 8 combinations. If I have 8 bits, I can get 2 power 8. 2 power 8 means 2, 4, 8, 16, 32, 64, 128, 256. So total how many combinations I can get? 256 different combinations I can get. That means there are 256 possibility to specify different instructions. That's what he has mentioned here. I think clear? So that's what he has mentioned. Okay. So I will go to my spotlight. Okay. And here we need to specify the registers. Okay, that's what we have discussed. Next, if the processor has 16 registers, then 4 bits are needed to identify each register. That's what he has told. If I have 16 registers, numbered from 0 to 15, R0, R1, R2, R3, R4, R5, and so on. Okay, so how can I mention them? By, for example, if I want to specify register R5, how I have to specify? Means in the binary form it should be written as 0101, isn't it or not? If I want to indicate register number 9, how can I indicate 1001, isn't it or not? So what he is trying to say, if I have 16 registers, okay, 16 registers means the number starts from R0 to R15. The value starts from R0 to R15. If I want to specify, or if I want to specify register number 7, how can I write in binary form 7, 0, 111, isn't it or not? For indicating 11, how I have to represent 8 plus 2 plus 1, 1011. Okay, that means what he is trying to specify as is, if I have 16 registers, for example, how can I represent 15? 15 will be represented by 4 ones, isn't it or not? So what is the main theme he wants to say is, if I have to n number of registers, I have to use log n to the base 2. This is the concept in your STLD. If I have n number of registers, how many variables I need to represent them is log n to the base 2. That means log 16 to the base 2. You will get 4 as an answer. So that's what he has mentioned here. So for 16 registers, we need 4 bits. Similarly, if I have 32 registers, I need 5 bits. 2 power 5 will be 32. If I have 64, I need 6 bits to represent those 64 registers, isn't it or not? That's what he is trying to express here in this concept called opcode. Okay, so along with the additional bits, along with these additional bits are needed to indicate that register addressing mode is used for each operand. Okay, so along with the registers, what we are using, he needs to specify, the opcode is going to specify somewhat important character, that is which type of, by using which addressing mode you have written the instruction. That means you may use register addressing mode, register indirect addressing mode, immediate addressing mode, indexed addressing mode, base indexed addressing mode, relative base indexed addressing mode. So there are n number of addressing modes now. So which addressing mode you have used in order to represent the instruction, that is also, that information is also going to be specified in this opcode. So opcode means it is an operational code. So generally the first priority or first thing what an operational code has to do is, it has to what you will call hold the thing, or operational opcode has a holds the instruction what we are going to perform. That means whatever the instruction we are going to perform, it will be written in a language that is understandable by that particular processor or controller. It will be referred as opcode. That means ADD, SUB, MUL, DIV, all these come under the concept of opcode. Okay, along with these instruction short forms, it is also going to do some extra tasks also. What are those extra tasks means? Along with the operational code, that means what is the operation we are going to perform. Along with that, it is also going to see on whom we are going to perform the operations. That means on two registers, or one register and one memory location, or one register and one memory, or one register and one immediate value, on whom we are going to perform this operation. That is also taken care of this opcode. And also the type of addressing mode we have used, whether we have used immediate addressing mode, register addressing mode, register indirect addressing mode, or what you will call direct addressing mode. Which addressing mode you have written the instruction, on which addressing mode we have what you will call expressed to the operands, that also will be taken care by this opcode. Okay. And one more thing what they are going to specify is, for example, if I encoded the opcode in 8-bit, okay, then I have 8 bits. By using that 8 bits, I can perform, or I can encode 2 power 8 possible specify different instructions. That means if I have 8 bits for instruction encoding, just now we have to discuss now, we can have 8-bit 8-bit opcode, 16-bit opcode, 32-bit opcode, like that. So if I have 8-bit opcode, I can use 2 power 8, that means 256 different instructions. Okay. By using that 8-bit opcode, I can perform, I can what you will call develop 256 different instructions. Okay. If it is of 16-bit, I can have 2 power 16, 2 power 16. Okay. 2 power 10 is 1 KB, 2 power 16 is 64 KB. That means I can have 64 KB different types of opcodes I can develop. Okay, that's what he has mentioned. Next, if I have 16 registers, 16 different registers, for accessing those 16 different registers, I need 4 bits. If I have 32 different registers, for accessing all the 32, I need 5 bits. That means if I have n number of registers, I need log n to the base 2 number of bits. Okay, that's what that was specified here. Next. So coming to the next slide. So next slide is about memory location and addressing. Memory location and addressing. First of all, what is mean by memory? Memory is nothing but a part or a region where we used to store the data, isn't it or not? So what is the purpose of memory? What is the purpose of memory? Means, see, what is a program? Program is nothing but set of instructions. So if you develop any program, it has multiple number of instructions. Okay, so along with the instructions, in between you are having different values, isn't it or not? Along with the multiple number of instructions, we are having we will get different intermediate values also. Okay, so that means, see, for example, I have an instruction. Yeah, let me explain what is mean by that. For example, my main concept is to perform this operation A plus, or if not, if I want to specify the registers, R1 plus R2 minus R3 divided by R4 into, where is this? Okay, I will leave it here. Okay, for example, if I want to perform an operation like this, R1 plus R2 minus R3 divided by R4. So for your clarity, I can still make it simple like this. I will place the entire values in a bracket. So what is the thing that is going to be happen means, first of all, there should be an addition between R1 and R2. The result value is going to be subtracted from R3, and the obtained result is going to be divided with R4. That is the meaning of this particular instruction. Okay. So this is after executing this particular instruction, I am going to get my final value, isn't it or not? But our computer is not going to perform all these operations in a single instruction. it needs at least 2 to 3 instructions to perform this task, because in one instruction it is going to add R1 and R2 values, okay, and it will store the result in some R3 register or R1 register somewhere. It may store in R1 and R2 also, there is no problem, okay. Next, for example, it's stored in R4 R5 register, some R5 register. Later what it has to do, it has to subtract the value of R3 from the value content in the R5 register, because we have stored the value of R1 plus R2 in R5 register. So we have to subtract the R3 value from that R5 register, then we will get some value, okay. Then we have to divide the obtained value with R4. We have to divide the obtained value with R4, okay. So that is the concept what we need to perform. So here, what is the concept of this memory location means, in order to perform, so once you perform this particular operation, we are going to get the final output. We are going to get the final output, isn't it or not? Before getting the final output, we have several input values. That means we might have assigned some value to R1, we might have given some value to R2, we might have given some value to R3 and also R4. So these values are to be stored initially now. Next, whenever I perform R1 and R2 initially, the value has to be stored in R5. R5 is a register. Registers also need to be stored in the memory itself, okay. Next, whenever I subtract R5 value with R3 value, then also I am going to get some value that is also to be stored in the register, okay. Next, whenever I divide R4 with that value, I am going to get some other value which needs to be stored in some memory location. That means whether it is the initial value or intermediate value. Intermediate value means the value that obtained when I perform R1 and R2 addition, and whenever I subtract R3 with the added result, whenever I divided R4 with the obtained result, like that, okay. Whether it is initial value, intermediate value or final value, okay, the value has to be stored in somewhere. That somewhere is nothing but a memory location. That somewhere is nothing but a memory location, okay. So that is the purpose of a memory. That means memory is used to store the numbers, instructions. What is a program? Set of instructions. Where we will store the program, that particular program is also going to be stored in the memory itself. That means values are going to be stored in the memory, instructions are program, that is nothing but set of instructions, they are also going to be stored in the memory. So how can the memory stores all this data? Means memory is nothing but combination of millions, lakhs or 10 lakhs of small cells, okay. Those are called storage cells. So memory is nothing but combination of small binary cells. Those are called storage cells, okay. Every cell can store only 1 bit of binary data. Every cell can store only 1 bit of binary data. That means every cell can store either 0 or 1, which are the machine language values which will be understandable by the computer. Though I give some R2 is equal to 54H, our computer will convert 5 as 0101 and 4 as 0100, and it will store those values in the cells, because every cell can store only 1 bit of binary value. Binary value in the sense it may be either 0 or 1. It cannot store other values. Is it clear or not? Okay. So eraser, yeah. Not right. So here, what is mean by word? What is mean by word length? Okay. See, word means in a memory location, if I want to store some group of or bunch of values, okay, that means whenever I want to store, I can store only that many number of values. Whenever I retrieve the data, I can retrieve only that bunch. That means it is like a bunch of grapes. That means whenever I hold any of what we'll call ఇప్పుడు అది ఎలా ఉంటుంది అంటే మనం ఎప్పుడైనా అలా తీసుకున్నాం అనుకోండి గ్రేప్స్ ది, ఆ బంచ్ వచ్చేసింది, ఆ బంచ్ కి ఎన్ని గ్రేప్స్ ఉంటే అన్ని వచ్చేస్తా ఉంటాయి. ఇక హియర్ ఆల్సో the word means the memory is organized in such a way that group of n bits, Word is nothing but group of n bits which are going to be stored sequentially. If whenever I take the value, then all the n bits are going to come. Just like whenever you take any grapes, what you will call stem. మీరు ఎప్పుడైనా గ్రేప్స్ ఒక గుత్తి తీసుకున్నాను అనుకోండి, ఆ గుత్తికున్న గ్రేప్స్ అన్ని ఇలా వచ్చేస్తాయి కదా, మళ్ళీ అక్కడ పెట్టినప్పుడు ఆ గుత్తి వెళ్ళి అక్కడ ప్లేస్ అవుతుంది కదా, గ్రేప్స్ కానీ ఏమైనా కానీ. సేమ్ కాన్సెప్ట్ ఇక్కడ కూడా అమ్మా. సో word means they are group of n values. Okay, so they are group of n bits. Okay, whenever you store, those n bits are going to be stored in one place only. One place in the sense they are not going to be stored in one memory location, because one memory location consists of one cell which can store only one bit of data. Okay, they are going to be stored in the consecutive memory cells. For example, if it is a 16-bit register, that means 16 binary values are going to be stored in one by one in a consecutive memory locations. If it is a 32-bit, then 32 bits 32-bit register, then 32 cells are being occupied by this particular register. That 32 cells also should be consecutive. That means varsa kramamlo undali. Okay, whenever I try to take the value, all if it is 32-bit register, all the 32 values will come at a time, but not 4 values, 6 values, 8 values. Okay, if it is a 16-bit register, whenever I try to take those values, all the 16 values are going to come at a time. Okay, so this is called as word. Okay, and the word length will vary. Word length means the n value, that means either they are 8 bits or 16 bits or 32 bits which are arranged in a sequential manner, which cannot be separated. Whenever you take, all the values will come at a time, is called word length. Okay, the word length means if 8 bits are 8 consecutive memory cells are being occupied, then by a particular value, then its word length is 8 bit. If 16 consecutive memory locations are being occupied, then it is called 16-bit. Okay, like that. Okay, so generally higher the word length, higher will be the speed of the operation of a computer, because if the word length is, word size is 32-bit, what does it mean? That particular processor can perform that operation on 32 bits in a single clock cycle. If the word length is of 64-bit, then it can perform the operation, either it is addition operation or subtraction or multiplication or division, whatever the operation, on 64 bits in a single clock cycle. Like that, this concept will come. Okay, so higher the word length, higher will be the speed of the operation. If the speed of the operation will be high, obviously the efficiency is also going to be high. Okay, so that is the word and word length. Generally 8086 microprocessor word length is 16-bit, whereas 8051 controller is only 8-bit. That means 8086 microprocessor can perform addition, subtraction, multiplication, division, whatever the operation, on 16 bits in one clock cycle, whereas the 8051 controller can perform addition or subtraction or multiplication or division on only 8 bits in one clock cycle. That means the 8086 microprocessor is double times faster compared to 8051, because 8051 is of only 8-bit microcontroller which can perform operation on only 8 bits in a single clock cycle, whereas 8086 can perform operation on 16 bits on a single clock cycle. That means the speed of operation of 8086 is double compared to 8051. Okay, so that is nothing but the word length. Word length, for easily understanding, you just remember the bunch of grapes. Okay, whenever you try to take them, they won't come individually, that entire bunch of grapes are going to come. Okay, whenever you try to place it somewhere, they won't split. Now that particular bunch is going to be placed at one place, so that will be referred as word, which cannot be, which that means all the particular n-bit locations, they are going to be filled sequentially. Okay, it will be called as word length. Higher the word length, higher the speed of the processor or controller. Lower the word length, lower will be the speed of operation. That means it will take a lot of time to execute if the word length is small. Okay, the rest of the topics we'll discuss in the next class. Okay, thank you.